Awesome. So it's great to be here. Normally, I talk a lot about Micro Frontends and about Module Federation, but today I want to show you what's possible with Module Federation beyond Micro Frontends. And for this, I start with a very important topic, namely Monkey Island. Who knows Monkey Island? Oh, great, great. So if you ask me, it's one of the best adventure games. I really enjoyed it when I was a child, and perhaps you've seen it. There is a new version from it. Since about 2 or 3 weeks, there is a new version. I finished it this week, so I now know about the secret of Monkey Island, which is quite amazing. However, when I played it for the first time, I was on a budget. My PC was not that great. I had an old PC, and that's why it looked like this here, which is really a nightmare. And also the sound was not good. I have placed a link here in my slides. You can check it up afterwards. The sound was not really nice. It was this PC speaker. However, a friend of mine, Christoph, had a better PC. His father was a teacher, and so they had a really great PC, and there it really looked like this. VGA graphics, which was the best available back then, and the nice sounds. They had a sound blaster. Really cool. However, somehow we had the same installation, the same version of this game. I really know this because we shared disks. I had a backup. I took care of his backup, you know. You never should have your backup at home. No questions on this. And yeah, we had the same system, the same version, and even though it behaved completely differently. And the reason for this is the PC itself is a plug-in system. You have this motherboard, and you can plug in extension cards like a sound blaster or a graphics card. And Christoph had the better cards. He had VGA and the Sound Blaster. I had nothing, just this monochrome display. And if you look at this from a technical perspective, then you could say, well, the main board is somehow consuming an interface, isn't it? And on the other side, those cards are implementing the interface. And the best of this is IBM, the vendor, the inventor of the PC, does not need to know much about other companies like Sound Blaster delivering those cards. They are really decoupled, and nevertheless, they can extend the system. Perhaps this is one of the reasons why the IBM PC was that successful. So if we transfer this to the world of Angular, the question is, how can we implement such a plug-in system with Angular? And this raises another question, namely, how can we load separately compiled and deployed code into our application? Somehow we need to load this code, even though we didn't know it at compile time. And this is one of the 3 things I want to show you today. For this, you can totally go with Module Federation. However, there are 2 additional things I want to show you. When we look at the agenda, I will just start with a 101 for Module Federation, just to get everyone into the boat. Just a tiny amount of slides. Then we will go on with the plugin system. We will look at A/B testing, and we will look into improving build performance, which is always a topic when it comes to company-based applications. Before we start, let me introduce myself. I am Manfred. I am a trainer and consultant for Angular, and I'm focusing on Angular for enterprise-scale applications. I'm doing a lot of workshops, consultancies, and trainings in this area. I'm quite connected to the Angular community. You hear it in my accent. I come from Austria. I do a lot of stuff here in Germany. Normally, I'm each and every second week here, traveling around the federal countries, helping people with enterprise Angular. And sometimes I'm even allowed to enter other countries if I promise to behave well. Most of the times, this works out. Okay, let's get started with the first chapter I've prepared for you. This is about Webpack Module Federation 101. As mentioned before, the main question that is answered here is, how can we load separately compiled code? we want to have something like this, an import that grabs over and loads the plugin from over there. And this is totally possible with Webpack Module Federation. With Module Federation, you get two kinds of applications, two roles of applications. The first role is the host. The second role is the remote. Both is configured by means of Webpack. The host gets some URLs mapped. Here I'm mapping the virtual URL mfe1 to something that points to over there. And over there, the remote can expose files. ECMAScript modules containing everything: classes, functions, components, routes, ng modules. It's up to you. Normally, the host is not interested into your file structure. And so normally you assign an alias here. You see it here, the alias is CMB. That means the host does not need to know that the file is called this/that/myComponent.ts. And when you have done something like this, something beautiful happens. Everything you need is a dynamic import. And dynamic import using the map names, and so it points over there, it grabs something from over there. The best of this is that Angular does not even recognize that something special is going on. From Angular's perspective, this is just lazy loading. Angular sees the import and says, lazy loading. Angular does not even know that underneath the covers, Webpack is grabbing something from over there. That means you can use Angular as is. You don't need to tweak it, you don't need any dirty workarounds, you just use it as is, as it was intended to be used. Another cool feature is you can totally share dependencies. You can say, well, I'm using Angular, you are using Angular, so just let's load it once and share it at runtime. Because it does not make sense to load Angular 10 times just because of having 10 micro frontends. By the way, sharing is always an opt-in. All the roles need to agree to share. It's like in real world. If I want you to share your test set with me, you need to opt in and I need to opt in. Otherwise, it's not sharing, it's theft or something like this. Okay, to get started, you need a little tiny plugin. You can use this here. We wrote this several months ago. It is just activating Module Federation in the CLI. You know, the CLI ships with Webpack. Webpack ships with Module Federation, so it's there. You just need to turn it on. And this is done by this little tiny plugin. You can run a schematic to get your configuration file generated. Then you need to adjust this configuration file. You ng-serve your application and pops your uncle. And this is a great deal for micro frontends because here you need to load something that was separately compiled into the middle of your shell, but you can also use it for other things like, for instance, plugin systems. When we move over to plugin systems, the first question is, well, how can we load those plugins without knowing them upfront? When it comes to plugins, we don't even know the number of the plugins upfront. Hence, this mapping here from short names like mfe1 to URLs does not make much sense. We don't know it. So the trick here is to get rid of those mappings. And instead of import, you move over to some helper function. A helper function that gets all the key data for loading stuff from the plugin at runtime. This will talk to Webpack at runtime, and this will make Webpack to load it from over there. The best of this is, here we are just talking about strings. That means all those strings like the URL or the component name can be retrieved from a configuration file or from some API that tells you, well, today I have those 5 plugins for you, tomorrow I have 2 additional ones for you. Let's have a look into this. The example I'm using here is a very simplified version of a customer project. And this is about a workflow designer. I can drop some items, some actions here to my workflow. I can download here some data. I can analyze data. Oh, before I'm analyzing data, let me quickly switch something out. Seems like I destroyed something during my stress rehearsal. We will come to this. I can download stuff. I can analyze this stuff. I can enrich the data. I can upload the data. The best of this is the workflow designer does not even know about all those tasks. They can be plugged into the workflow designer. Different companies, different vendors can create their own tasks. So if you are specialized into image processing, you could provide image processing tasks. If you are specialized into text-to-speech, then you provide tasks for text-to-speech. Here you see such systems. This here is providing the upload and the download action, and this here is providing the analyze and the enrich action. Everything this workflow designer knows about is this configuration file. It comes from a server-side API. At least this is what I think about it. In my example, it's hard-coded, but never mention it. And here you see this piece of information tells us, well, today I have, let's say, a download task. It comes from over here. An upload task. It also comes from over here. And an analyze task, which comes from a slightly different origin. Yeah, and then the workflow designer hooks everything up. If we look into the implementation of all of this, first of all, we should have a look at our Webpack config. This is the Webpack config of one of the vendors. And you see it's pretty slim. All you need to do is to say, well, let's expose something under the name download. It's this component. Let's expose something under the name upload. It's that component. That means the host, the workflow designer, can now load those components from over there, even though it did not know it at compile time. And here we are sharing. Here I'm quite generous. I'm sharing everything. It's easy to get started with share all. It just looks into your package JSON and shares everything found in there. Perhaps it's not the most optimized way, but it helps you to get started quite quickly, and then you can opt out from sharing this or that. Okay, this is the side from the vendor. When it comes to our workflow designer, the workflow designer is actually pretty simple. It has a for loop, and it loops through all the items you've placed on your workflow. And for each and every item, for each and every application, it is just rendering a plugin proxy. A proxy component that gets all the metadata, like, hey, this action can be found over there. If we look into this proxy component, then you see the template has just a placeholder, an ng container that acts as a placeholder. And this placeholder is referenced via a view child. We get it in as a view container ref. And in order to load our action, we just call this helper function, which is a part of our package for module federation, load remote module. It takes the metadata that has been passed in via an input. So it loads the module from over there. This is an ECMAScript module. Somewhere there is an exported Angular component. The name of this Angular component is also dynamic. It also comes out of our metadata. I'm grabbing it out, and then I'm putting it into my view container, and pops my uncle. Awesome, that's all. That's really all. At the end of the day, of course, you have this lookup service that shows you which components are available. Just think about this like some server-side API that tells you about what's possible today. Now, let's go on. Let's come to the second thing I've prepared for you. Let's do some A/B testing. I think you all know about A/B testing. It's about not giving all the users the new features. Perhaps you want to try out some new features for a little tiny friendly user group, get their feedback and use the feedback to improve the feature for the others. This is totally possible with module federation. Just switch out the metadata you are sending down to the users. Just send down the adjusted metadata to the friendly group of users. Let me show you this in action. So let's say this is our metadata, and let's say we have a new analyze task, an AI analyze task, where some kind of Android is analyzing everything for us. And let's say we have an if here. Just imagine an if. Some users get this, and some users get the all task. I am one of the lucky friendly users. I can download stuff. I can analyze it, and this is the Android, so perhaps we should switch out the picture. Let's see if people like it, and then we can enrich it and upload it. So it's all about switching out stuff on a dynamic basis. Okay, the third thing and the fourth chapter is something that is important for everyone who is doing enterprise scale applications. It's about improving build times. And the idea here is quite simple. If I subdivide my application into several applications, I just need to recompile the changed ones. For this, I have here a showcase. I have an artificial application. Everything is generated. And it consists of 10 micro frontends. You could also call it 10 parts, 10 business domains, as you want to call it. And each of those 10 parts have 20 features. That means, and I did the math by my own, I'm very proud of this, we are talking about 200 features here. And all those applications are separately built, and we can load them into the main application, into our shell. In order to find out what has changed, I'm going with NX. Perhaps you've heard about NX. Some of you are using NX for sure. And so you know it's a really beautiful tool for Angular development. Not only for enterprise development, but also for enterprise scale development. It gives you a lot of additional things that comes in very handy when going with huge applications. And it works not only with Angular, but also with other frameworks. Here we have just some of them. One of the best features of NX is the build cache. It caches everything you did in terms of ng-build, also in terms of ng-lint and ng-test and ng-e2e. And if nothing changed in this or that portion of the application, the task is not re-executed. You get the result immediately. If you change something a little tiny bit, it's using hash values internally, then it's re-executed. And so this really helps me to just re-execute the build, the tests for the changed vertical slices, for the changed parts loaded with module federation into my shell. Let's have a look at the result. When I have a cold cache, that means the cache is empty, then building those 200 features takes about 1 minute on my machine. Seems like I'm on a budget again. History repeats. When I have a warm cache, when everything is in there and nothing changed, it takes less than a second. How cool is this? However, honestly, having everything in the cache and having nothing in the cache, both is boring. Because it's obvious, if everything is in the cache, it takes no time, and if nothing is in the cache, it takes a lot of time. It gets more interesting when there is something in the cache and something that has been changed. Here I just changed one of the applications. One of my vertical slices, one of my, let's call it micro frontends, and so just this one application was recompiled. It took me about 10 seconds, give or take, on my machine, which is quite a difference. The remaining parts have been taken out of the cache, so it was quite fast. And I also saw this out in practice. I've helped several companies in the last months and years with this approach. And as you see here, this really allows to cut down your build times. It scales almost in a linear way, and this is really beautiful. Okay, let me show you a demonstration for this. Perhaps we should have a look into the application first. So this is my NX-based application, and when we look into the libs folder, we see some domains. I really like to subdivide my huge applications into domains that reflect different parts of the real world. And if we look into a domain, we see 20 features, 20 feature libraries. And the feature libraries, of course, contain traditional Angular code like a component. Nothing special in here. And now, when I want to build, let's say, my domain 10, because only domain 10 changed, then it works immediately because it's already in the cache. If everything is there, I get everything immediately. If some little tiny parts have been changed, only those little tiny parts need to be recompiled. So how does this work technically? Well, technically, if you don't configure anything special, and if you don't use any cloud solution, you get the node modules folder.cache, and in there is an NX folder, which has a lot of further fancy folder names. And those folder names cache the results of your builds, of your tests, of your lintings. The names here are just, hash values calculated over your source code. That means if you change a little tiny bit, you get a new hash value and you don't find something in there for your vertical, for this part of your application. If you don't change a thing, the hash value stays the same and NX grabs it from out there. Caching locally is a good start. But if you really want to have the best build performance, you need a shared cache. You need to share one cache with your colleagues. In this case, you don't need to recompile something your colleagues already recompiled. And your colleagues never need to recompile something you already recompiled. And you benefit from everything the build server did and vice versa. So it is a positive effect. And to get such a global cache, you can configure NX. There are several ways. You could use a file share. You could drop in your very own strategy for caching, or you could go with the NX Cloud, which is offering a paid offering you can use to cache in the Amazon cloud, or even in your Kubernetes cluster. In this case, they give you a Docker container. Global cache, make sure that you benefit from things everything else was doing. If you like this topic, you find more information here in my free ebook. You can download it under this link. And if you don't like this topic, download the ebook anyway. Perhaps it helps you to like this topic a bit more. Okay, let me come to a conclusion. What did we see today? Well, we saw that all of this is about loading separately deployed and compiled code. Code we did not know at compile time. And this allows, of course, for micro frontends, which is quite a huge topic nowadays, but it also brings other benefits like plug-in systems. Think about the Alt BC, think about my workflow designer, things like A/B testing, things like heavily improving the build performance. And one last thing, please always remember this one last thing. Monkey Island is really an awesome game. Look it up. Thank you.